Hello, everyone. I want to go over your music tech questions assignment. I'm going to go over the answers as well as going over the analog and digital and focus mostly on analog and digital. Hopefully, this doesn't take too long, but this will be on the second half of the assignment for the science of sound waves. So first, what is music technology? Very simply, it is using tools to make music. It's any tool that makes music can be considered technology. Of course, nowadays, modern technology allows musicians and composers to record, compose, edit, and mix music or tracks using computer and software. That's a very kind of simple, basic definition. What's the role of the Industrial Revolution's impact on music? So again, this is, a lot of your answers will vary, but during the Industrial Revolution, recording live sounds became common. So in the later 1800s, we had the telephone, we had electricity for a little bit, but the telephone recording sound, transmitting sound, that became one of the main features. As a result, factories and rise of the modern industry allowed for the production of better quality music instruments and the use of personal recording and playback equipment. So in the, again, early 1800s, late 1700s, if you wanted to hear a concert or anything like that, you would have to go and maybe buy a ticket and go to a theater, go to a concert hall and listen to music. But as really, it was after the Civil War, especially in America, that a lot of military bands they actually sold their instruments because the war was over. So as a result, a lot of people started buying cheap instruments from the Civil War and earlier. So that was kind of starting to get the brass bands and things like that, and what eventually became what's very common for military bands and brass bands was marches. So in the late 1800s, you saw the march, different styles of marches. If you want, one example is John Philip Sousa, who you probably know. He became very popular composer of American marches. On the other side, we also have music instruments that could be made cheaply. Because now we have a factory as opposed to everything being made by hand. So things like guitars, violins, anything made from wood could now be, the wood could be processed faster, cheaper. It's cheaper to transmit it, cheaper to buy it. So a lot more people are now buying instruments and just kind of like making a hobby out of it as opposed to just listening to music. And of course, once we get the recording equipment, you no longer needed to learn how to play an instrument to make music. You could buy a recording, and the early 1900s. And this is kind of going into the digital, but the first recordings were analog, and then later they became digital. Of course, the recording quality wasn't great in the beginning, and we'll talk about how all of that occurred. Digital revolution impact on music, significance of computing. You kind of made this all one question as opposed to three separate 5-point ones. So digital revolution, starting with computers, allowed sampling. We'll talk about after the next project. Composing, playing, distributing music simpler and cheaper. Computers also made ways for artificial and electronic sounds not possible with acoustic instruments. Composing, recording, synthesizing, editing, adding effects, producing, engineering, distributing. Basically, all of that became simpler and more readily available once the computers, kind of entered the everyday life in the 80s, 90s, and especially now. To elaborate a little bit on basically this sampling, composing, playing, distributing music. The first part of that, when you're talking about composing music, everything had to be handwritten. Again, back in the pre-digital revolution and industrial revolution, 1900s, early 1900s. If you wanted to write a letter, you had to handwrite it. If you wanted to write a piece of music, you had to handwrite it. If you wanted to make a copy, you had to make a copy by hand. You had to physically have it piece of paper, you have another piece of paper, you copy everything down. So it was very inefficient, a very long process. Once the printing press came up, you could print multiple hundreds, thousands of pages. So once you composed one piece of music, you could now, make a copy. You can sell it easier. So before people started kind of making recordings, you could buy sheet music, and you could learn to play piano and kind of entertain your guests who were coming over for a dinner party. Same thing when it comes to distributing. Basically everything became simpler and cheaper. And then right in 1929 and early 30s, when you had basically the Great Depression, the stock market crashed. A lot of publisher companies, a lot of music publishers, and just any printing press in general, they kind of went under. They all went out of business, and it kind of very slowly resurrected after World War II ended, and as a result, the kind of in the 50s, 60s, you kind of go into the digital revolution with the rise of computers and all the digital stuff. You don't have to know what all of these words mean if you don't synthesizing, editing. But basically everything that we're doing in class now, we're doing digitally. Mixcraft, Soundtrap, all that stuff is all digital. We're doing a lot of editing, adding effects. We will be doing some synthesizing, of course, recording, all that stuff. Again, very briefly, between a music producer and audio engineer, two different people, two different functions, two different jobs. So an audio or a recording engineer, that's another term for it. Audio engineer, sound engineer, recording engineer, it's all the same thing. They're all synonyms. That person sets up and operates the soundboard. So he's the one physically behind the mixer, and he's controlling all the levers. He's doing all the technical stuff. Operates other recording equipment. So he sets up the microphones. He makes sure all the things are, turned on physically. Everything's wired. Everything's, kind of safe as well. So everything during a recording session, while the producer brings the direction of the sound, the writing, and the techniques to the artist. So that's when the producer might say, maybe sometimes it involves writing music, composing music, but most of the time it's just the direction of the sound. The producer is, in a lot of cases, in charge of how the album or how the song itself will sound. So he's the one that says, oh, we're going to add a darker layer, we're going to make this poppy, we're going to add this kind of sound to it, which does require actual writing, composition. So, some of those roles could be between the artist and the producer themselves, but they're the ones that kind of have a general idea of where, the sound will go, where the band will go. And a lot of producers are, behind the actual sound of the artist. If you listen to an artist and you say, oh, I like that sound, I like the instrument they're using, whether it's acoustic guitar, electric guitar, piano, synthesizer, the musician probably can play, piano or synthesizer or digital keyboard, or they can play acoustic or electric guitar. But it's the producer that decides, this part's going to be on the acoustic guitar. Then when the chorus comes in, we're going to bring it to electric with this effect. So they're the ones that have a lot of the kind of, again, direction of the sound, the kind of the brain power behind what the music will actually sound like. Whereas the recording engineer just makes sure that, that effect is applied. They have the correct guitar, everything's tuned, the strings are new. They're using this sort of amp. Basically, the recording engineer might take a lot of direction from the producer. The producer will say, make sure that, we're using, solid state, whatever amp, as opposed to a tube amp, or, maybe whatever it is. In a small environment, both roles can be done by a single person. Sometimes it's a person in the band that's doing the producing and, engineering. That depends. Usually the bigger the band and the more money they have, they hire more people to work on them. So usually a smaller, not as popular band, you would have, either one person or, several people in the band, taking those tasks. All right, for the main part, analog and digital. And this is in a way a quiz, and this will involve all of your sound wave stuff that was on the previous video, as well as all of this stuff, because this does have to do with sound waves. So the question is, what is the difference between analog and digital audio signals? Which one is usually higher quality, better fidelity, and what is the advantage of using each one? So just to give you the definition straight out, right? Analog is a smooth, continuous form. It is a physical imprint, and it is usually onto some kind of vinyl or a magnetic tape. It is the true recording of a sound wave. It usually is warmer and higher quality, usually, but it also takes up the most space, and because it's physical, it can be damaged or degraded on repeat playings. So to give you some analogies, so you probably you may not know specifically analog digital music and sound waves in that sense, but you know what an analog clock is, you know what a digital clock is. So you know your smartwatches, all that stuff is that's all digital. But before the 80s and even now, analog clocks are very popular, and they have gears. They have physical gears that actually physically move the second hand and all the different, basically the little pin needles. So there are some pictures here to show you that there are physical components to the clocks, and that's kind of this is kind of like an older clock. Basically, there's a lot of mechanism. One gear turns another gear, and then there's a mechanism that keeps everything moving and keeps everything on track. A digital clock, there's nothing to see. There's just basically a little digital screen, whether it's LED or anything else. There is nothing to see. There's basically a computer chip with a screen, and that just tells you the time. Nowadays, because we have very complex digital smartwatches, you can have something that has an analog screen on it, but that does not make it an analog actual component. Another example, if you look at a typewriter, that is an analog component, where you have something like this. You can see a very old one. They're all very old because they were replaced by machines. You put a piece of paper and you would feed it, and you'd use these little levers to make sure it's being held in place. When you type a letter and you press on the key, it physically punches, there's a little imprint. It punches it onto the paper, and that's how you type, and that's how you used to send letters. And so it's at least usually faster to write once you get used to it than handwriting. It's less tiring. It's easily read, right? You don't have to decipher someone's handwriting. So there's a lot of, again, physical components and all of these things going on inside of that. Nowadays we have the digital, something like, this, right? When I create a new document, everything is just there. I can type, right? I can delete. I can type a little bit. I can copy. I can go and paste it. I can change the font size, right? So that's all digital. That is all digital. That's exactly what everything kind of means in that sense. Everything that's analog is physical, right? Again, physical. There's really a lot of examples. The first light bulbs, where you could say they were like physical. You could say like a lantern, right? Where you have a candle, you light it. You have physically, something's actually burning, right? The wax is keeping the flame going. Whereas a light bulb, you just kind of flick the switch, electricity, boom, everything works. You see, there's light. So that, is another example. So hopefully that kind of gives you the difference between all the different, or just the difference between analog and digital, not necessarily for music, but just analog and digital. Digital always requires a computer, some kind of a processor or a chip or whatever. Analog is always physical, always. So when we're looking at waves, right? An analog is always a smooth, continuous form. It is a physical imprint onto a vinyl or a magnetic tape. So when we're talking, oh, I actually have. So we have right here. So this is a vinyl record. Here, let me just put you vinyl record. Vinyl record. Right. You probably also all know these. You've seen them at least. If you zoom in, you will see that it's a vinyl record, and it is physically imprinted with sound waves. If you zoom in, you will see again, this is the needle, and you'll see the actual grooves, and this is the actual sound wave that is recorded. The first vinyl records, they came up very low quality in the 20s and 30s, but even before that, they were just like wax cylinders, and then they were metal, and then they kind of evolved into vinyl that is now very high quality, as opposed to digital, which is just something that it's converted to code using a computer chip. So to give you a definition for digital is a sound wave converted into a digital signal, which is binary, which just means it's zeros and ones. It's code. It's just it's like DNA. If you studied that, yeah, everything is just zeros and ones in a string of numbers, and it's converted back into music. Basically, you record something, it hits the microphone, it's converted into a code in the computer, and then when you want to hear it, that code is converted back into sound. So because it's converting, the sound into a code and then back into sound, you are losing some of the quality, right? So it can be high or low quality depending on the format, and it always takes up a lot less space than an actual analog physical imprint. But as a result, it is much more convenient to be played, recorded, recreated, streamed. You can record something onto your phone, upload it to YouTube. Someone across the world can hear it in 10 minutes. And that's the advantage of modern technology. But you are losing some sound quality, right? Because the wave itself is converted into code, and then that code is converted back into sound. There's there's a loss to the conversion. Whereas the analog stuff, it's the actual physical wave. If you were recording my voice onto vinyl, there is no disruption. There is no conversion. My sound, with the sound waves coming out from my mouth, they hit the recording equipment, and that needle physically cuts into the vinyl onto the tape. It is a physical imprint. So there is no loss of any audio quality. Big definition. Analog is a continuous recording onto a physical format. The needle reading grooves on the vinyl and played through a speaker is an example. Digital takes very short snapshots of audio, thousands per second, and that's what the code is. So that depends on how high quality that becomes, and that converts that signal into code using a microchip and then back into sound transmitted through a speaker. So this is an example in the first one up top. This is an analog wave, right? It's continuous, it's smooth. If you were to zoom on the digital wave, you would not have a smooth wave because it would be converted. So you would have snapshot here, snapshot here, snapshot here. So this is kind of one example. It's more like a bar graph. I will use Audacity, and I'm going to import my sound again. And I had, let's use this. Okay, so, from here, it looks like everything is, more or less smooth, right? Everything's connected. But once you zoom in, especially on this example, you can see that this one little tiny section is just one snapshot. What I mean by snapshot, so something like this, right? So you have, this is what digital representation, basically this is what digital representation of what a sound wave is when it's converted digitally. Instead of one continuous wave, you have hundreds, if not thousands, of individual screenshots that are played back to back so that you're forming one continuous sound, right? One wave, one sound, but it all looks like this. And you can see that this is, if we start right at the beginning, or let's start at second, this is zoomed in so far, right? This is 28, here we go. So this is second 28, this is 28.1. So this is 1/10 of 1 second. This is 1/10 of 1 second. And then you get to, very, you can't even play this selection because it's way too short. Again, this is 1/10 of 1 second. This is 1/20th of 1 second. And you can see that these are, again, this is a digital program, so it's going to show you the snapshots, essentially. But you can't just look at one snapshot. What does it sound like? It's going to make no sense out of context. So that's why all of this kind of exists as is. So that is the answer. Again, analog is a continuous recording onto a physical format, whereas digital takes short snapshots of audio, converts the signal back into code. To give you one example, or to elaborate a little bit more, I'm going to open Mixcraft. You have Hertz, right? HZ. So your standard quality is 44.1 kilohertz, which is 44,000 hertz. But you can go up to 48,000, 96,000, 192,000. You see it's doubling from 48, 96, 192. What this means is that your recording device is taking snapshots at that rate, meaning that you have 44,100 hertz, which is your regular CD quality. If you were to listen to a CD, it's recorded at 44,100 hertz, which means that your recording device is taking 44,100 snapshots each second. So that's what hertz means. Remember, it's waves per or cycles per second. So 44,000 hertz means that your recording device, your microphone, is recording it 44,100 snapshots per second. So if you take that, flip book, right, and you put 44,000 papers and you play them all in 1 second, that's why you do not hear any breaks when you listen to your digital audio, because it's recorded at such a high rate. But this is actually the lowest rate nowadays, 44,000. 48,000 is your regular DVD quality audio, 96,000, 192,000, even higher. So 48,000 hertz to 96,000 hertz, you have 96,000 snapshots a second. And your ear, honestly, scientifically, cannot tell the difference between 44,000 and 48,000 clips per second. Never mind 96,000 or 192,000. So the quality, really almost doesn't matter, because essentially when you zoom into that point, there is no, the difference between 44,000 in a second, 96,000 in a second. Your ear cannot decipher that. Oh yeah, I heard 44,000 individual clips. It absolutely cannot. So, that's the main difference. Analog, it is one wave. That's it. One, beginning, end. There is no breaks. There is no snapshots. It's one continuous wave, physically imprinted onto vinyl, onto magnetic tape, onto, onto anything. Usually it's vinyl because it's the highest quality nowadays. Digital, converted into code, and then back into a sound wave through your speakers. But it always requires some kind of a microchip or a computer or processor, all that kind of stuff.